Big welcome back to all pupils from Buile and all pupils across the Concilium Academy Trust. Today's lesson is on concentration of solutions, and by the end of this lesson I'm hoping that we can apply our understanding of moles that we've learned of previously to calculate the concentration of a solution and be able to express that solution as either grams per decimeter cubed or moles per decimeter cubed. This lesson is for all pupils in year 10 and 11, and it doesn't matter whether you're doing combined science or GCSE chemistry. As always, before we move on, we need to check our progress, and so what I'd like you to do is to try to answer the 3 questions on screen which have appeared in previous lessons. Pause the video now and then we'll check our answers in a short while. Okay, the answer to the first one, calculate the relative formula mass of NaCl. The answer to that is dead simple, 23 plus 35.5, the answer is 58.5. Just out of interest, that 58.5 is 1 mole of NaCl. Remember that the mole of any substance is its relative formula mass in grams. So the second question, where it says calculate the mass of 3.25 moles of NaCl, well, you know what 1 mole is, it's for 98.5. So 3.25 moles will be 58.5 times 3.25, and therefore the answer will be 190.125 grams. And the final question, how many moles of NaCl are there in 14.625 grams? Well, moles is equal to the mass divided by the relative formula mass. So the mass in the question is 14.625. We know the relative formula mass is 58.5. Divide those two, the answer is 0.25 moles. I hope you found that useful. I hope you did well. And if you didn't, maybe you should have a look back at the videos that we've done previously before moving on. Okay, 2 glasses, and we're going to fill those 2 glasses with exactly the same volume of water. And into the glass on the left, we're going to put in 5 grams of glucose. We're going to tip it in and we're going to dissolve it. And in the second glass, we're going to put in 10 grams of glucose. So what we've got is we've got 2 glasses of sugary water. But the one on the left with 5 grams in it has a lower concentration of glucose than the one on the right. And you could test that by just giving it a sip, couldn't you? The one on the right with 10 grams of glucose in it would taste more sugary. In our GCSE exams, we're going to have to be a little bit more accurate than saying low concentration or high concentration. We're going to have to be able to express it accurately. And to do that, we need to learn a new unit of measurement. And that new unit of measurement is a unit of volume. And the volume that we're going to have to use in these calculations is a decimeter cubed of water or any other solvent. Now, a decimeter cubed of water might not mean much to you, but if you think of a litre of fizzy pop, the litre of fizzy pop has a very similar volume to 1 decimeter cubed. Another thing we're going to have to do is we're going to have to talk about the relationship between decimeter cubed and centimeters cubed, which you're probably more used to hearing. Well, 1 decimeter cubed is equal to 1,000 centimeters cubed, and we're going to have to use that later in this lesson. So if I take my 5 grams of glucose and I add it to that 1 decimeter cubed, what is the concentration of that water solution? Well, to do that, we're going to go back to our triangle. And you can see that concentration is equal to mass divided by volume. So if I put my hand over the concentration there, that's going to tell me that mass divided by volume will give me the concentration of this solution. The mass of glucose is 5 grams. The volume of the liquid that we've got is 1 decimeter cubed. So very simply, the concentration of that solution is 5 grams per decimeter cubed. Let's try another example, and in this example let's have half a decimeter cubed of water, and we've still got the same 5 grams of glucose, so we'll put that 5 grams of glucose into that half a decimeter cubed of water. So we know that concentration is mass divided by volume. So this time the mass is 5, but the volume has changed to a half, so concentration is going to be 5 divided by a half. So therefore the concentration has changed. It's 5 grams per decimeter cubed. Okay, so some practice then at expressing concentration in grams per decimeter cubed. There are 3 questions on the screen. You've got the triangle on the screen also to help you. Pause the video now and answer those 3 questions. Okay, the answer to the first one then, 100 grams in 0.2. will be 100 divided by 0.2 decimeter cubed. The concentration will be 500 grams per decimeter cubed. The second one is 12.5 divided by 0.55, which gives a concentration of 22.73 grams per decimeter cubed. And finally, if you put 32.7 grams of glucose in 2.25 decimeter cubed of water, the concentration will be 14.53 grams. Hope you did those well. Okay, let's take the next step then. Let's make it slightly more difficult. So let's say that we've got 125 centimeters cubed of water. Notice it's no longer decimeters cubed. And I put 5 grams of glucose into that 125 centimeters cubed of water. The thing you need to be very, very careful of is if you're expressing your answer for concentration, it has to be in decimeter cubed. So even though we've got centimeters cubed of water, at some point we're going to have to convert it to decimeters cubed. So there's our triangle, and we know we're trying to find the concentration. So let's work it out. So concentration is mass in grams divided by volume in decimeters cubed. Look again at that for that line there, decimeters cubed for volume. So we've got 5 grams divided by 125 centimeters cubed. So at this point, let's turn that 125 centimeters cubed into decimeters cubed. And to do that, we're going to have to divide it by 1,000 because 1 decimeter cubed is equal to 1,000 centimeters cubed. So that will then therefore allow us to go 5 grams divided by 0.125 decimeters cubed. Look at that line again. I've now converted those centimeters cubed into decimeters cubed, so I'm nearly ready to get the answer correct. So we're going to go 5 divided by 0.125 in our calculator, and the answer is 40 grams per decimeter cubed. Okay, so let's practice then that skill, practicing the skill of turning centimeters cubed into decimeters cubed. There are 3 questions on the screen for you. Let's practice those now. Okay, how did you get on? So the first one, 15 grams in 750 centimeters cubed is going to be 15 divided by 0.75 decimeter cubed, which will give us an answer of 20 grams per decimeter cubed. And the second one there will be 122.5 divided by 0.105 decimeters cubed, which gives us an answer of 1,166.67 grams per decimeter cubed. And the final one will be 3.5 divided by 0.065, which gives us an answer of 53.85 grams per decimeter cubed. So we've mastered 2 skills already. The first skill was to actually express concentration as grams per decimeter cubed. The second skill is to do the same, but we have to convert the centimeters cubed into decimeters cubed first. So the third skill is to actually express concentration as moles per decimeter cubed. So let's work through an example of that. New triangle, and the only thing different about this triangle is I've converted at the top there, that first part is, instead of mass, it now says moles. Okay, so let's say I had 500 centimeters cubed of water, and into that water I dissolve 5 moles of glucose. Okay, so to calculate the concentration then, it's moles divided by volume. So I've got 5 moles, and I've got 500 centimeters cubed of water. Let's convert that into decimeters cubed of water. So it will be 0.5. So it'll be 5 divided by 0.5, which gives us an answer of 10 moles per decimeter cubed. Okay, I've only given you one basic example of how to express concentration as moles per decimeter cubed, but there are 3 questions on the screen for you now. Pause the video and have a go at all 3 of those. How did you do? So the first one will be 2.5 divided by 0.650, giving us an answer of 3.85 moles per decimeter cubed. In the second one, it will be 3.75 divided by 1.25 decimeters cubed, which gives us an answer of 3 moles per decimeter cubed. And the final one, we've got 0.15 moles. We've only got 80 centimeters cubed of water. Be careful with this one. It will be 0.15 divided by 0.080. And the answer will give us 1.875 moles per decimeter cubed. Well done if you got all those right. Okay, proper challenge then for you to finish. This question would be worth maybe 5 or 6 marks on a GCSE exam and is a challenge. So it says calculate the concentration of a solution in moles per decimeter cube. So that's the first thing to know, is moles per decimeter cube. But we've got 18 grams of C6H12O6 and it's added to 250 centimeters cubed of water. The masses of carbon is 12, mass of hydrogen is 1, and oxygen is 16. Okay, pause the video now and have a go at seeing you can answer that question, and then I will go through the full working out of how to get to the answer. Okay, so it's a multi-step question, and the first thing that we're going to have to do is calculate the relative formula mass of the compound. So C6H12O6, the mass of that is 180. So the number of moles of C6H12O6 that we've got is equal to the mass in the question divided by the relative formula mass. So that will be 18 grams in the question divided by 180, which means that we've got 0.1 moles of the compound. So really what we've done in that step is we've taken the fact that in the question it tells us we've got this amount of grams. What we've done is turned it into moles, and that was important because it wants us to give our answer in moles per decimeter cubed. So the next step, concentration is equal to moles divided by volume, and now we're on easy street, so it would be 0.1 divided by 0.250 decimeters cubed. So I've converted 250 centimeters cubed in the question into 0.25 decimeters cubed, and in the calculator the answer will be 0.4 moles per decimeter cubed. Proper challenge, proper difficult question. Well done if you got it right. Maybe if you didn't, maybe you want to now rewind the video and try again. Okay, well done everybody. Hope you found today's lesson useful. Please make sure you're following us on Buile Science Instagram's page. Take care everybody, look after yourself.